today. This is an old electric motor made in Germany from Gebr Kaiser, and it's dating back to around the early 1900s. It will run on both alternating current and direct current. I've hooked it up to direct current here because it seems to work better and the motor seems to run a little bit faster that way. I didn't dare to put it up to 220 volts direct current, which this motor is rated for, because there are open contacts and loose wirings all around there. So before I put myself to death, I better hooked it up to 24 volts and made a rectifier, soldered a rectifier to it, and it runs now on direct current. The entire motor is very well built. The bronze bearings have absolutely no play in them, and the entire motor weighs about 15 kilos, and all massive cast iron and very, very neatly manufactured. These are the screws for adjusting the tension on the sliding contacts, and I insulated the wires over here that lead from the contacts to the sliding contacts. I insulated them with some cloth wrapped around them because they were just blank wires around there, so I decided that doesn't need to be, and I basically just insulated them. The motor is hooked up to a board which I attached several links to. So you have the alternating current input, and below the board is a rectifier, and here you can DC output. Here you have a DC output where you can take off direct current 24 volts if you desire to. Otherwise, these wires lead to the switch, which controls motor on or off. And also you can put out alternating current if you want to. And the light bulb back here is just for fun because I had the threads and the holder lying around and an old burnt out light bulb. So you could theoretically hook it up to voltage. I have wired it below here. There you can see the two inputs for 220 volts, so theoretically this bulb would light up, but it's just there for the looks, and because I had empty space left back there, and I decided to fill the space. And basically this has sliding bronze sliding bearings, bushes, which are lubricated with a metal ring that goes around the axle and rotates and takes up the oil that is sitting in a bath down here and puts it over the axle, distributes it in the bearings. There you can see the metal ring that goes around there, and deep in the black below sits the oil that just lubricates the bearings. Here is a detailed view on the sliding contacts and the commutator. It's incredibly well balanced, although there is quite a bit of run out on the wirings, but I expect these to be all hand wound. And down here that cable links the two stator coils. Now this side is what I call the safe side, because there are no open contacts and no open wirings or whatsoever. Here you have the possibility to take off power over a pulley, and my original intention was to drive this motor, or to use this motor as a drive for my new lathe. I got a little bit bigger lathe. However, it turned out that this motor only has 1/8 horsepower, or around 90 watts. So that won't be quite strong enough for the size of the lathe. And also, as I said, there is the problem of the direct current that I do not have available. I have a small rectifier below here. However, that won't be strong enough to take the loads that would be exerted on it when you run it on 220 volts. So yeah, I just decided to put it up on the board and make it run just for show, so that it doesn't sit in a shelf and collect dust, or I hate when things that actually work fine just simply decay and are left over. And this is in a superb condition. I mean, when you hold it with your hand, there are no dead spots or so all the wirings are good. And even on full voltage, we tested it on 220 volts, but the motor makes literally no sound. The only sound that it makes are the brushes that are lightly touching the commutator, and they just make a very slight sizzling noise on high speed. And now it's a slight dark humming noise, which is not disturbing or anything. It's just very, very quiet. Now the current would pass from the minus pole on the board through this wire up into the coils. So these two coils would exit the coils, go into the rotor or commutator, whatever you call it, and pass through there and go out down here and pass through the switch, which interrupts the current as soon as you activate it. Yeah, I'm very happy with this installation. I didn't expect it to turn out that good. Yeah, I do think it fits the style quite nicely, and just a light bulb without any sense, just to look cool. Yeah, and this is just, the motor is maybe degraded down to a child's toy, but I just like the way it runs, and it's like, well, watching a fire in the firebox or anything. It's very, very interesting, and there are always new things you discover. They love to detail here, and everything is well thought through. You see, there are even screws down here to allow for changing the oil, and yeah, it's very, very, very ruggedly made. I think you could drop this from second floor and nothing would happen to it. And yeah, as I said, I do not have any exact data on when it was built, but judging by the style of the motor, I would say that it is approximately early 1900s. Like 1900 to 1910, somewhere in that date. Here are the oil ring bearings down there. And yeah, that's it basically. Thanks for watching. A very, very nice motor.